Hello and welcome to Code and Magic channel. In this tutorial, we're going to learn how we can draw a triangle via OpenGL. In the last tutorial, we created an empty window, as you can see here, with GLFW and GLAD, and now we're going to continue to draw a triangle in this window. Well, first thing first, we need to know how a rendering pipeline is working. OpenGL has a rendering pipeline, and the OpenGL rendering pipeline is a series of states and operations a GPU goes through to render 2D and 3D graphics on a computer screen. Some of these shaders are configurable by the developer, which allows us to write our shaders to replace the existing default shaders. We only have to work with the Vertex and fragment shader. The geometry shader is optional and usually left to its default shader. In modern OpenGL, we are required to define at least a vertex and fragment shader of our own because there are no default vertex and fragment shaders on the GPU. So we have to write our own shaders to replace these ones. Well, you may ask, what is a vertex? A vertex actually is a collection of data per 3D coordinates, such as position, color, etc. Well, and now let's write our own shaders. And here, after we load OpenGL function pointers, we continue to create our own shaders. Basically, we have to write our shaders in separate files, but to make things simpler, we just write them here in strings and use them. But in future tutorials, we write them in different files and learn how to load them from different files. Okay, well, let's start by creating a vertex shader. I will start with const char pointer vertex shader src, which is source, equals to, and here I put it in separate lines. And basically shaders are, we write shaders in GLSL language, which is OpenGL shader language, and it's very, very similar to C language. For example, I have a void main function, which will be a start like this, and I have to end it like this. This is our main function, but because this is just a simple string, I have to define the end of line, which is \0, and I have to define new lines by \n. So I have a very simple function here, a main function. But actually I have to write other things as well. For example, we have to specify the version of the GLSL we want to use, which is version 330 core, which is basically the version we have here, 3.3 core profile. \n, and we also have to specify a predefined variable, which is called GL position. This value is a vector4 value, and we have to define some specific points for this one. For example, X, Y, Z, and W. We will learn about the W component in future videos, but now consider that we need something to pass for this position. And vec4 actually is something for shader language that you can define 4 components, as I mentioned, like X, Y, Z, and W, which has 4 parts, and we have to pass this to GL position, and then it goes through pipeline. Okay, but now just let's leave it like this, but we will fill it right now. And we also need a variable, because here you see that we have to pass our points to this pipeline. So when we pass our points to this pipeline, it actually goes through the vertex shader. So we have to specify a variable to get this point. Because we're going to get this variable, we have to write it like this: in vec3 pose. This is just a name that we defined. We are specifying that we have an input, which is a vector tree, and we're going to call it a pose. But we also have to write something else behind it, which is layout location equals to 0. And basically, we are saying that the location of this variable is 0, and we're going to define some specification for this later. But just remember that we have to write it like this when you're going to get a position. Well, and now that we have the position, we have to pass it to GL position, variable, which is for OpenGL. We have to pass it like this: pose.x, pose.y, pose.z, and 1. Well, we also need the \n here. Well, basically, this is a very, very simple vertex shader. As you can see, it's just the main function. And first we defined its version, and then we get an input variable. We define an input variable, and then we pass this input variable to GL position. So this GL position will go through the next stage. Well, we have to define another variable, actually a vertex shader, which is very, very similar. A fragment shader, which is very, very similar to vertex shader. Const char pointer fragment shader. I can basically copy and paste it here, but we have to change some part of it. Well, its version is 3.3 core. It doesn't have a layout. It's actually, we have to output this value. Basically, we have to write something like this: out vec4 frag color. Actually, we are saying that this fragment shader, we're going to return a frag color from this shader, and we don't need this anymore. And finally, the color of the triangle will be the color that we define here. Frag color equals to vec4, and now this 4 component will get an RGBA color. For example, I can define a red value, or because the background is red, I'm going to something like blue. Red, green, blue, and also the alpha channel as 1. So this is the blue color. We can also combine it with green to have a yellow color. And well, now we define our vertex shader and fragment shader. The vertex shader has an input, and the fragment shader has an output. Okay. Now the next step is to create the actual shader, because these are just the strings. These are just two strings, and we have to create the actual shader. And to create a shader, we have to first define its ID somehow, and signed int vertex shader equals to GL create shader. With the function GL create shader, we can create a shader, and we can pass the type that we want, which is GL vertex shader. And now we define its ID to refer to it whenever it's needed. Okay, now we just created an empty vertex shader, but we have to define that, okay, this is your source code. Well, and we have the function GL shader source. And in this function, we pass vertex shader one, and now we have to pass the actual source. Vertex shader src, and for the last parameter, which is the length of the shader, we pass 0, and OpenGL determine it itself. So the first parameter is the ID that we defined, and we're going to create to attach one shader, and then this is the source code, because it's the pointer we define here with the @ sign to pass the actual data, and a 0. Now we have to compile the shader. We define the shader, we attach the source, and now we have to compile to make sure it is compiling successfully. Just this shader. GL compile shader, and it gets a shader which we pass vertex shader, the actual ID. Now to specify if it was successful or not, or if there is an error, where to save the error, we have to define a variable called success, int success, and we're going to define a character array to store error information, char info-log with the length 512 to store if there is any error. Okay, GL, now we have to test if there is something wrong about this compilation. We have to call the function GL get shader IV, and we have to pass the vertex shader here, vertex shader, and what we want is the compile status, GL compile status, and then return if it was successful or not. Well, now it tries to get the information if it was successful or not, and if it wasn't successful, we're going to check what was wrong. And we call the function GL get shader info-log, and we pass the vertex shader, and the buffer size is 512, and the length we pass 0 to OpenGL determine itself, and info-log. We're saying, okay, if it wasn't successful, try to get the info-log about the error, and then store it in the info-log. Now we can print the error. failed to compile the vertex shader, and error equals to, and actually error is info log end of line. Okay, now if I run the program, I will see if there is something wrong. Now we don't have any log, which means the shader, the vertex shader, is working correctly. We have to do the same thing for the fragment shader. I have to define an ID for it, and signed int fragment shader equals to GL create shader, and we want a fragment shader, and we have to define the source code GL shader source, and we pass fragment shader as an ID, and also 1, and also the source of the fragment shader src, and 0 as a length. Also have to compile shader, GL compile shader, fragment shader, compile the fragment shader for us, and then try to get errors, GL get shader IV, fragment shader, and GL compile status, and then return value to success. And if it wasn't successful, then do the same thing. Get info and get shader info log for fragment shader, and print failed to compile fragment shader. Okay. To make sure it is working correctly, we can try it by removing something, as an example, a semicolon from vertex shader, and check if it is still working. And as you can see, it says failed to compile vertex shader, syntax error, because we removed the semicolon. Okay, now it's working. Well, and actually a fragment in OpenGL is all the data required for OpenGL to render a single pixel. And the main purpose of the fragment shader is to calculate the final color of a pixel, and this is usually the stage where all the advanced OpenGL effects occur. Usually the fragment shader contains data about the 3D scene, and it can use the calculate the final pixel color, like light, shadows, the color of the lights, and so on. Well, and now that we defined two shaders, we have to actually create another thing, which is shader program, and attach these two shaders to that specific program. Well, we have to create a shader program, and we have to first define an ID for this, unsigned int shader program, and GL create program. Okay, now we have a shader program, and we have to attach the shader that we just created to this program. GL attach shader, and we pass the shader program ID, shader program, and we also pass the ID of the vertex shader, vertex shader. It is saying that attach the vertex shader to this program, and we can do the same thing for the fragment shader. And after attaching, And we have to link program, which is basically something like compiling. GL link program. It's trying to see if it can create the pipeline. And shader program. And we're going to link program, link status, and return to success. Tell us if it was successful. And what am I missing? GL link status, shader program. Yeah. I'm sorry. We don't have to pass these two here. For link program, we just have to link and then GL get program IV. And then we have to shader program, and then we pass these two values here. It tries to link program and then tries to know if it was something wrong. And then if it wasn't successful, it tries to output the result. GL get program IV info log, and then we pass the shader program here, and then failed to link the shader program. Well, let's see if it is working. Well, yes, no errors. Well, we basically created a shader, a vertex shader, we created a fragment shader, and then compiled them to make sure they are working correctly. And then we just created a shader program and link those two shaders to one program, and then compile that program and link that program to see they are connecting correctly. And now they are all working. Now we can delete these two vertex shader and fragment shaders because they are inside shader program, and we can just use shader program and we don't need them anymore. So to free resources, we can delete them. GL delete shader, vertex shader, and also fragment shader. Can delete them to free resources. Now the next step is to actually draw a triangle. Well, let's come here to explain it a little better. Imagine we're going to draw a triangle like this, and if we consider this as a y-axis and a x-axis, let's imagine that this is the y-axis and this is the x-axis. It goes through -1 to 1, and here -1 to 1, because OpenGL only processes 3D coordinates when they are in a specific range between -1 and 1 on all three axes, which is x, y, and z. All coordinates within this normalized device coordinates range will end up visible on your screen, and all coordinates outside this range won't. Okay, now this is what OpenGL understands between -1 and 1. Now that we're going to create a triangle, we have to specify 3 points, which is this one, and this one. And the position of these 3 points are, for example, for this one is minus 0.5 and minus 0.5. And for this one, the y-axis is minus 0.5, and for the x is just 0. And for this one, the x-axis is 0.5, and for the y-axis is minus 0.5. So basically, these are three vertices that we need, so we can define them in our program. I'll create a float vertices array, and I can define the point that we defined here, which is minus 0.5 for the x, minus 0.5 for the x-axis, and also 0 for the z-axis, because it's just a 2D triangle. We don't want to use the z-axis. Well, this is just the first point. This is just the first point, and we can copy this for the next vertices as well. Okay. The next one is minus 0.5 and 0. And the next one in the z-axis is just 0.5, and for the y, minus 0.5. Okay. Now we have the vertices that we need. And with this vertex data defined, we'd like to send it as an input to the first process of the graphics pipeline. The Vertex Shader, which is actually the Vertex Shader, we're going to send this to Vertex Shader. And this is done by creating a memory on the GPU where we store the vertex data, configuring how OpenGL should interpret the memory, and specifying how to send the data to the graphic card. Well, to do that, we have to define something called vertex array objects and vertex buffer objects. We start with the vertex buffer object, unsigned int vertex buffer object, and basically we have to generate a vertex buffer object, gl gen buffers, and then we need one buffer object, and we pass the vertex buffer object here. Now it just created a vertex buffer object, and the next step, we actually have to actually OpenGL has many types of buffer objects, and the buffer type of a vertex buffer object is a GL array buffer. We can bind the newly created buffer to the array buffer target with the GL bind buffer. So here we say GL bind buffer, and we pass GL array buffer, and we also pass vertex buffer object. And what happened is that we just created a buffer object, vertex buffer object, and we bind that buffer object, and we specified the type, which is array buffer, and then we have to pass the data to this memory on the GPU. We call the function GL buffer data and GL array buffer. We specified the type, and now it's asking for the size, which is size of vertices. And actually, once the data we pass the vertices, well, for the next one, it is asking for the usage, and we can pass 3 usage, and like GL stream draw, GL static draw, and GL dynamic draw. And we pass the GL static draw. But for other ones, which is the stream draw, we have other things like GL stream draw. This one is when the data is set only once and used by the GPU at most a few times. And GL static draw is the data is set only once and used many times. And this is what we needed. We are only setting the data once and we're going to use it in render loop a lot. And the next one is GL dynamic draw. GL dynamic draw, and it means the data is changed a lot and used many times. And we can pass these three values for here as the usage. And for this triangle, we have to pass the static draw because we only set it once and use it a lot of times. So, and this is the data. And the next step is we have to specify for the program to how interpret this vertices. How does it know that this is the first vertex and this is the next vertex and this is the last vertex? Well, we have to do that with the function GL vertex attrib pointer. Here it is asking about an index and we have to put 0 because this 0 is actually this 0 that we defined up there, because this one is the specification. Actually, this is the specification of the variable oppose, and we have to define it here. Okay, its size is 3 because it was a vec3. And its type is float, and we pass the GL float, which is an OpenGL type. And it is asking it should be normalized, and we say no, GL false. And the stride, it is asking about the stride, and actually the stride is the space between each vertex. And because each vertex is exactly starts after the next vertex, we can pass 0 to OpenGL determine it itself. But we can also pass like the size of floats multiply 3, which means these are floats and we have 3 floats per vertex. If we pass the size of float per 3, it will understand that, okay, it is 1 byte, it is 4 bytes, 4 byte, 4 byte, and it becomes like 12. Finally, it becomes 12 bytes. So we can pass this. And for the last one, it is asking about the start of the vertex, which is 0. But because its type is void pointer, we have to cast it to void pointer. So we cannot basically just pass 0. We have to cast it to void pointer. Okay, and the vertex attrib array is basically false by default, and we have to it basically disable, and we have to enable it. GL enable vertex attrib array, and we have to pass 0, and this is the index that we explain it here, and we have to enable it. And well, we just created a memory on the GPU, which is vertex buffer object, and we bind the GL array buffer and specify the type that we need, and we fill the data inside that memory, and then we defined how the data should be interpreted in that memory, and then just enable it. And we need something else, which is called vertex array object to actually save all these specification. So whenever we need this data, we just bind the vertex array object and just use it. We don't need to define it every time. Vertex array object. And we also have to generate a vertex array object here, which is glgen vertex array one vertex array object. And we also have to bind the vertex array object. GL bind vertex array object. We actually have to do that before binding the vertex buffer object, because the vertex array object actually saves what is going on inside the vertex buffer object and everything. And then now that we defined the vertex buffer object and enabled everything, and we have to unbind after all of this. And to unbind, we have to just, the way we bound stuff, we just unbound. And instead of passing these values, we pass 0, which means unbind. And well, what happened is that we created a vertex array object and vertex buffer object. We generate them and store the IDs here. We bind them, we bind the vertex array object, we bind the vertex buffer object, and then we fill the data. And we defined what this data means, and we enable them, and then we just unbind them. Okay, so whenever we need this information, we just have to bind the vertex array object. For example, in the render loop, I want to draw the triangle. I just need to bind the vertex array object, and it knows how to read data from vertex buffer object, and we don't need to specify these things every time. Okay. And we also create a shader program, and we have to, in the render loop, we have to use that shader program, and we can see here GL use program, and we pass the shader program. And we bind the vertex array to know how to read data. And then we have to specify GL draw arrays. And what we want actually is a triangle. So we pass GL triangles. And the first vertex is 0 and the last vertex is 3, because we have only 3. And then now we should be able to draw our triangle. Let's try. Well, as you see, we have a triangle, but the shape of the triangle is weird. We have to check what's wrong inside the points that we created. The first point is 0, minus 0.5, minus 0.5. The next one is actually in the x-axis, it shouldn't be -1, it should be 0.5. Actually, the x-axis should be 0. And then in the y-axis, it should be 0.5. Now it should work correctly. Well, now the triangle is correct. Okay. And the next thing that we have to do is to free resources after the while loop. Actually, we have to delete the program. After the while loop, we have to delete the memory that we created inside GPU. We also have to delete the vertex array object. So we pass the GL delete program, and we delete the shader program, and GL delete buffers, and we pass we want delete 1, and this is the vertex buffer object, and we have to also delete the GL delete vertex arrays. Well, this is how we draw a triangle, and this is basically the hardest part of in OpenGL. If you know how to draw a triangle, you know most of the things to continue. Well, thank you for watching, and if you like this video, don't forget to hit the like and subscribe button. And in the next tutorials, we'll see how we can draw a rectangle, and we continue. Thank you for watching.